So let's continue our look at quadratics. We're going to look at two topics today. The first is domain and range, and the second will be how to write quadratic equations that ask for a specific criteria. So let's start with domain and range. Remember that domain is the same thing as what you are inputting into a function. We previously worked with domain when we had problems like the square root of 2x over x minus 1, where you had to think about you can't have a 0 in the denominator, and underneath a radical has to be greater than 0, or 0 if it's in the numerator. Domain is really thinking about what is allowed to be plugged in for x. And for range, we'll be looking for the output, right? When we plug in certain numbers, what are the types of numbers that we get out? In this picture here, think, right, domain is what we're plugging in, or our x value, and range, that's going to be what we get out, or our y value. So let's talk about domain and range in terms of quadratics. So here we have y equals x squared minus 2x minus 2. Well, let's start off by graphing it and finding all the information we need to find. And we just want an easy sketch, so let's start out by finding the vertex. Now you could put this in vertex form, right? Right now it's in standard form, but I'm going to go ahead and find the vertex by finding our axis of symmetry, right? Our negative b over 2a, that's going to equal our x value. If we do that, we're going to have negative 2 over 2 times 1, which is equal to 2 over 2, which is 1. So we know our vertex has the coordinate 1 something. We can plug it in to find the y value, 1 squared minus 2 times 1 minus 2, and that's going to give us a y value of 1 minus 4, which is a negative 3. So our vertex is 1, negative 3. How about finding the y-intercept, because that's nice and quick and easy, right? It's in standard form, so boop, right there, that's our y-intercept. It's going to happen at the point 0, negative 2. And this really is, we just want a very brief sketch. This is enough, right, from the last video to be able to sketch a graph of it. And this sketch will help us determine the domain and range of our quadratic. So we can plot our points. Here is 0, negative 2. And we also have the vertex at 1, negative 3. We can, right, don't forget that our vertex, the x equal to 1, that's also our axis of symmetry. So if you wanted to, you could put your dashed line there. Thinking about the fact that a parabola is symmetric, if 0, 2 is on it, we also know then, or 0, negative 2, we know then that 2, negative 2, right, because it has to be symmetric over that axis. And then that's going to allow us to just give us a nice easy sketch. We can look at this graph to help us decide the domain and range. Remember, domain, if we look up here, is the same thing as what we're allowed to put in. So as we look along the x-axis here, do I have any restrictions, right? No, I don't. We can plug in every single x value, so that means our domain is going to be negative infinity to infinity. Now, how about the range? The range, right, that's our output, or our y values. So here, notice the range is restricted between these two numbers. Well, if we look at our graph here, what's happening, right? These arrows mean that this graph will continue in the positive, up in the positive direction forever. But how about down here? Do we have any sort of y values that we're not getting out of this function? Well, our lowest value will happen here at the vertex, right? So we're looking at the y value of the vertex as our lowest value. And that, in fact, we're going to call a minimum value. And that means our range will include that minimum y value of negative 3, because again, our vertex, the y value is negative 3. But then our graph, right, does it have an upper value or a maximum? No, it doesn't, because these are going to go on forever. So our upper value will be infinity. So when you're dealing with quadratics, the way to find the range is to think about, where is my vertex, right? If we find the vertex and we know if it's a smiley or a frowny parabola, that will help determine the range. If our parabola goes upward, right at smiley. Our range will be the y value of this vertex to infinity. How about if our parabola is going down? Here we're going to have a maximum value, and our range in this case will be negative infinity up to our y value. When dealing with quadratics, your domain will always be all real numbers. It's the range that you need to think about. And you don't necessarily need to graph it, just think about what my vertex is, what's the y value of my vertex, and then is it a smiley or a frowny parabola? The second part of this video will now be looking at writing equations. So how about if a quadratic has a vertex of 5, 2 and passes through the point 2, 1, what's the equation of that quadratic? And remember, when we're writing the equation of a parabola, we can choose to put it in standard form, vertex form, or intercept form. And the big hint here is it's giving us the vertex, so let's write it in vertex form. So vertex form is y equals a x minus h all squared plus k, and we know the vertex is 5, 2. So let's plug those values in. We'll get y equals a x minus the h value plus the y value of the vertex as k. We're almost finished with our equation. The only thing left is to figure out the a. Well, let's see. We have one more bit of information in this problem, and that's that it goes through the specific point with the coordinates x, y being 2, 1. Well, we can substitute those in for our x and our y and then solve for a. So we'll get our y value is 1 equals a. Our x value is 2, then minus 5, and that's all squared, plus 2. Now we're just solving for a. 1 equals a. Let's simplify in the middle here. 2 minus 5 is a negative 3. We're going to be squaring that, so that'll give us 9 plus 2. 9a will equal, I can subtract 2 from both sides and get negative 1. A will equal a negative 1/9. So if I rewrite this as an equation, I'll get negative 1/9 x minus 5 squared plus 2. Let's try writing one more equation. Here we have x-intercepts of negative 1 and 2, and it goes through the point 1, negative 6. So which of our forms, standard, vertex, or intercept, do you think you will use for this problem? And what's kind of telling you that? Well, it's telling us we're going to be thinking about our x-intercepts, so that's the form we want to use. And remember, intercept form is y equals a, x minus one of your intercepts, and x minus, let's call that x minus m and x minus n for our two intercepts. Now plug in what you know. Let's put negative 1 for our m and 2 for our n, which that's going to then give us a times x minus a negative 1 is x plus 1, and then x minus 2. Now it's similar to the previous problem. We're left with only solving for a. We can use that point we know has to be on this equation to solve for a. So our x value is 1, our y value is negative 6. So negative 6 equals a, what we're solving for. Our x is 1 plus 1. Our x is still 1 minus 2. Negative 6 is equal to a times 2 times negative 1. So negative 6 equals negative 2a. A is going to equal, if we divide by negative 2, 3. And putting everything together, we're going to get 3 x plus 1, x minus 2. So in both of these problems, you can see that whether you're given the vertex or the intercept, you first want to identify the form you're going to use. And I would suggest writing that form down. Right, there's vertex form, there's intercept form, and then you are plugging in the information that you know. If it's vertex form, plug in the vertex. If it's intercept form, plug in the intercepts. Then you'll be left with just a, and there you're going to plug in. Both of these problems are giving you an extra point that's on your equation. And with that, you can solve for the a. And that's it for your third lesson on quadratics.